Welcome to episode 8 of the Head in the Clouds video series. I am Ken Hartman, a SANS certified instructor and content creator for the SANS Cloud Security Curriculum. Today's episode is titled Programmatically Access Google Secret Manager. The purpose of Head in the Clouds is to teach foundational cloud skills and security knowledge that will help others thrive in the cloud. The content ideas come from my personal observation of skills that I see some students lacking when they show up to a SANS Cloud Security course. Other ideas are passed on from fellow SANS instructors. Today's topic draws from some recent private consulting work. I wrote some automation to authenticate to a SaaS application and download a backup file. The proper protection of the authentication secret is a primary concern because an attacker with the authentication secret could impersonate this backup service and download all of the data. In fact, the Cloud Security Alliance identified this as top threat number 4 in their Top Threats to Cloud Computing, the Egregious 11 publication. Credentials and cryptographic keys must not be embedded in source code or distributed in public-facing repositories, such as GitHub, because there is a high risk of discovery and misuse. Keys need to be appropriately secured with a well-secured public key infrastructure to ensure key management activities are carried out. In my case, even though the code was to be stored in a private repository, I intended to follow the best practice of keeping the secret out of the source code. To set up the scenario for this Head in the Cloud session, we need a web application to authenticate to, and then we need to write some code for the client-side service to use to perform the authentication. Once that is working, we will refactor our code to pull the authentication secret from GCP Secret Manager. Setting up Secret Manager involves adding a secret version and creating a service account with permissions to read just that particular secret. I considered setting up a WordPress server for this episode, but then I remembered the KISS principle. Keep it simple, stupid. Instead, we will use httpbin.org, as it supports making an authenticated REST API call. Open this page up in an incognito window in Chrome or the private browsing feature of your favorite browser. We are using incognito mode to prevent the browser from caching the credentials. Expand the auth methods and then click the top one, Basic Auth. This will take you to httpbin.org #auth get basic user password page. Next, click the Try It Out button. This will open up a form for us to configure the username and password strings that the server will expect. Enter HITC as the username and 123456 as the password. I know, it's a terrible password, but I couldn't think of a worse one. You may have noticed that the clear text password is in the URL. You can ignore that, as that is simply how httpbin.org keeps its configuration without requiring users to log in and create profiles for testing REST API requests. Of course, if this was a production system, yeah, that would be a big deal. After you have entered the 2 required fields, hit the Execute button. This will cause a form to pop up that prompts us for the credentials that we just configured. Enter them correctly into the pop-up form and hit the Sign In button. Paging down on the web page, we can see that we received a HTTP response code of 200, which indicates a successful authentication for this server. The web page also shows the response body and the response headers as well. Let's repeat the test with invalid credentials. Close all incognito pages to ensure there are no cached credentials. Now hit the Try It Out button once more. The previous credentials that we configured in the server should be cleared. Enter in the same credentials as before HITC for the username and 123456 for the password, and then click the Execute button again. This time, in the pop-up form, we will enter them incorrectly. Use HITC for the username and QWERTY, QWERTY for the password, and then click the Sign In button once more. The form will let you try again, but just click the Cancel button. Note that when we scroll down the page, we can see that the HTTP response code is 401 and that there is not a response body. Note, different API endpoints will behave differently. Some may return a HTTP response code of 200 and will indicate an authentication failure in the body. It all depends on the developer. To determine how your specific web service handles the authentication success and failure responses, you can use an intercepting proxy, such as Zap or Burp Suite. To learn how to do this, check out episode 7 of Head in the Clouds, Passively Evaluate a SaaS Provider's AppSec using Zap. Great. Now that we have a server to authenticate to, we need client-side code that will successfully authenticate to it. For this proof of concept, we will be using Python because it is a very popular tool among security professionals. Python uses libraries that can be imported as needed, and these are called modules. The request module does most of the heavy lifting when it comes to formatting HTTP 1.1 requests. Fortunately for us, there's another online tool that can help us figure out the format of the GET request for the API endpoint that we just configured in the previous section. In another browser window, check out https reqbin.com. In the field for the URL, there is a default value that points to https://reqbin.com/echo/get/JSON, but we want to replace all that with the one from the server that we just configured. Now, let's try it out. Select the basic auth radio button and then enter cap HITC for the username and 123456 for the password. Click the Send button. Notice that we see 4 lines of content that indicate that our authentication was successful, and we get a HTTP response code of 200 OK. Click the Raw tab to see the response headers along with the response body. Click the Content tab again. Very cool. Let's repeat the test with invalid credentials. Enter HITC for the username and QWERTY for the password. Click the Send button. Now we can see that there is no response body displayed in the Content tab and that the response code is 401, unauthorized. We also know from the work that we did in the previous section that this is expected behavior. Change the password back to 123456 and send the GET request once more. Make sure that you see the 200 response code. Now, for the cool part, select Python from the Generate Code dropdown. Check it out. This tool even generated the basic Python code for us. Let's try that out. Using a Linux system with Python 3 installed, open a text editor with a new file called auth.me.py. Paste in the code generated by the previous step. Save the file and run it using the following command: python3 authme.py. We should get a value of 200 returned by the program. Let's make one little tweak to the code. Let's have it print the response body too. Save it and rerun it. We should see something like this. Look familiar? Recall that the /n is the line feed escape character. Take another look at the Python code. Notice the string SEUIQZOXMJM0NTY equal. What is that? Hint, it is not encrypted. It's a base 64 encoded value. Let's decode it. Aha! Our credentials are HITC:123456. What happens if we change the credentials that we have our Python program use? Let's change it to HITC:QWERTY. Well, that returns a base 64 encoded value of SEIUQZPXD2VYDHKK. Let's use that in a copy of our program called authme.py. When we run it, we can see what an authentication failure looks like. Now that we have a simple functional code snippet, let's get Google Secret Manager all set up and integrated with the code we wrote. Log into the GCP console and create a new project called HITC. In the search bar, enter Secret Manager and click on the Secret Manager link at the top of the results. Make sure that the HITC project has been selected. Enable the API and click the Create Secret button. Now we need to decide on a name. How about http://bin_auth? Now we need to enter in the value for the secret. Here we have a choice. We can provide just the clear text password 123456 and have the Python program concatenate it to our username and then base 64 encode the concatenated result, or we can enter in the complete base 64 encoded string. The latter follows the KISS principle and has the advantage of keeping the username out of the code. However, in a production system, most folks would store the clear text password and have the script concatenate it and encode it to make the rotation of the credentials easier on the administrator. We're going to enter in our base 64 encoded value as the secret value and then click the Create Secret button. Our next step is to create a service account with the permission to read the secret. Enter service accounts in the search bar and click the topmost link in the results. Again, confirm that we are still working on the HITC project. Click the Create Service Account button. Enter the name of the service as HITC-service. Click on the name of the service account to open the details page, and then click on the Keys tab. Click Add Key, choose the Create New Key drop-down. Select the JSON radio button and then click Create. Download the key to the system that has the Python programs that we were playing with earlier. Make a note of the name and full path of this JSON file. For example, while we're here, let's copy the email address of that service account that we just created. And then we're going to navigate to the secret manager. We're going to click on the secret to open up the details, and then we're going to click the permissions tab. Then we're going to click add. And in the new members, we're going to paste that email address. And the email address that corresponds to the service account will display. Click on it to select it. Then we need to assign a role. So we will give it the role of secret manager, secret assessor. And then click Save. While you are here, let's make a note of the resource ID of the secret. We can find that by clicking the Overview tab. Now let's create a virtual machine. Type VM in the search bar and choose the VM instances result. Enable the service and click the Create Instance button. We will accept most of the defaults except scroll down to the service account drop-down list. Select the HITC service and then click the blue Create button to launch the instance. Once the instance is running, let's connect to it using SSH from the browser. Now we need to apply updates and any dependencies. Run the following commands at the SSH terminal. Notice that the last command installs the Python module for interacting with Secret Manager. Now let's copy over the authme.py script. The easiest way to do this is to copy and paste the contents, so that is what I will do. And then, just as a sanity check, let's run the authme.py on our new GCE instance. Works great. Now to make our modifications. First, let's fork our code to a different file name. Next, we need to import our module to interact with the secrets manager and a function to fetch the secret. So insert the following lines at line 3. Then we need to substitute in our secret resource ID that we made a note of earlier. Next, we need to modify the line that contains headers, authorization, basic, and our basic forward coded value to read headers, authorization, basic, fetch secret. Also, note that there's a single space before the double quote after the word basic. After saving our changes, we can run the script to see if it works. And it does. Woohoo! Okay, but can we get this script to run on a system that is not hosted in Google Compute Engine? Yes, and that is where the JSON key file comes in that we downloaded. First, let's copy the authme.sm.py program back to our other Linux system using my copy-paste trick. But what happens when we run it? It throws an error because there are no credentials that can fetch the secret from Google Secret Manager. Don't despair. Let's read the last bit of the error message. Could not automatically determine credentials. Please set Google_application_credentials. Or explicitly create credentials and rerun the application. For more information, please see the following URL. When we go to the referenced URL, we read that we can set an environment variable that points to the JSON key file. So for me, that would be /home/ken/workspace hitc blah 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 .json. So I would run export Google_application_credentials equals that file with its full path. And now when we run Python 3 authme sm.py, it will successfully authenticate. Wonderful! Now you know how to abstract secrets from the code that will use them to integrate with other systems. Yes, you could have set the secret as an environment variable, but then you would not have any real control over how and when that secret is accessed, like you can with a solid secrets management solution, such as Google's Secret Manager. And by the way, in this short episode, we have just scratched the surface of what Google's Secret Manager can do. If you have thoughts or comments on today's episode, feel free to chime in on the comments for this YouTube video. If you appreciate this video and want to see more like it, be sure to give it a thumbs up. Stay tuned for another installment of Head in the Clouds, as announcements of new episodes are made on the SANS Cloud Security Twitter feed. Meanwhile, be sure to check out the other great videos on the SANS Cloud Security YouTube channel. Take care.